The required service program installation file is available on the Kröber website under Downloads, Software. Please download and unzip the installation file. First, install the driver for the USB port interface and then start the CDM setup file. Now plug the Kröber O2 device into the USB port of your PC and switch the device on. Windows will recognize the new hardware and automatically install the required driver. The Kröber O2 software can now be installed. The Kröber O2 main screen displays administrative data on the left, current numerical data in the center, and valve activity on the very right. Below that, the cycle settings are shown on the left, and a graphical representation of the current alarm condition is depicted on the right. The administrative data lists the serial number of the device, the serial number of the electronic circuit board, the operation hours of the device, and the current software version. It is possible to set the operating hours meter to a specific value. However, only the manufacturer can make this adjustment. Therefore, always provide both the serial number and operation hours of the device when ordering a replacement part. The center of the main screen displays current measurement data. The following measurement values are shown: the oxygen concentration, the current volume flow, the volume flow set, the pressure in the oxygen reservoir, the sensor signal quality. The normal range is between 80% and 100%. The following is displayed on the right side: the operating voltage of the circuit board, the gas temperature of the volume flow, the compressor chamber temperature, the opening width of the proportional valve as a percentage, the calculated speed of sound in meters per second. From this speed of sound, the oxygen concentration and flow rate are in turn calculated. Located in the right block is a visualization of the valve activity. Here, the selected intake and outlet valves are marked in red. The numerical control cycle is displayed above the depiction of the valve. The device starts in phase 0. This is also the case each time the device is rebooted, then goes into phase 1, then phase 2, then again to phase 1, and continues to alternate. Phase 255 indicates an error. On the left, the middle part of the screen displays the cycle times of the sequencer. From software revision 5.21 on, no manual changes can be made to these settings. The concentrator optimizes these figures automatically. On the right, the middle part of the screen displays a visualization of the alarm states. Active alarm states are marked in red. Alarms of low, medium and high priority are depicted on the top, middle and bottom row, respectively. If the oxygen concentration in the volume flow is less than 82%, an information message will be triggered. If the oxygen concentration in the volume flow is less than 60%, the low priority oxygen alarm will be triggered. If the sensor detection quality is inadequate, a sensor alarm will be triggered. The threshold for this is 20%. In the case of a permanent discrepancy between the actual and target volume flow, the volume flow alarm will be triggered. This alarm will be indicated both when it comes under and above. For security purposes, the alarm sound can only be disabled when it comes under. If the operating temperature in the interior of the concentrator exceeds 65 degrees, the temperature alarm will be triggered. Once the alarm is triggered, oxygen production will largely cease. This means that the exhaust valves will open. Phase 255 will be indicated. If the primary power supply fails, the power failure alarm will be activated. In this case, the circuit board will only be supplied by voltage from an energy storage device. The device will not be operational. 5 graphical traces are visible in the lower part of the screen. The top curve displays the graphical progression of the oxygen concentration of the last 60 seconds. only oxygen levels greater than 60% are represented. The second trace displays the volume flow. The third trace displays the pressure in the reservoir. The fourth trace is a graphical representation of the sensor signal quality figure. The bottom trace shows the opening of the proportional valve. History log. This form allows for the creation of a service report. User-related identification data can be entered in the top area. The left field displays device data and is automatically generated and displayed when the history is called upon. These are not to be altered. The right field provides the ability to document performed tests. During a self-test, the device turns itself on and reviews whether or not the necessary internal device functions are running correctly. If no errors are shown on the LCD display of the oxygen concentrator, the test has been passed successfully. During the compressor intake test, the intake opening behind the service cover will be sealed and the hoses will be checked for leaks acoustically. Following the test, the device sets the minimum and maximum volume flow and assesses the device parameters. During a visual inspection, all electronic and pneumatic connections are checked for tightness and proper condition. With that, the safety inspection is completed. Individual texts can be entered in the Remarks and Included Accessories fields. Finally, this log can be printed and saved. Also, saved logs can be accessed again at any time. History Status Report. The device provides the ability to analyze the properties and behavior, including adjustment and alarms of the last 16 hours to analyze with a type of black box or flight recorder. In the top area, there is the device identification information. Further down is up to 32 rows, each representing a summary of the device behavior. Every half hour is identified by an index number, followed by a measurement period of 1800 seconds, which is 30 minutes, and a bit mask, which can be decoded by the manufacturer. Booting the device is known to take 1780 seconds. The first three columns describe the cumulated times for alarm conditions, sensor signal quality, low oxygen, and volume flow. In the next columns, information about the closed-loop controller for volume flow can be found, proportional valve, detailed sensor quality, and volume flow. The following two columns have information about the proportional valve with average and maximum readings of the valve opening, followed by average and minimum pressure readings in the reservoir. The next two columns have readings of the minimum and maximum gas temperature. Subsequently, the average cycle times are depicted for the left and right columns. Finally, the average measured volume flow, as well as the minimum, maximum, and average oxygen concentration, is specified. An error-free report will appear as follows. There are no alarms present. The gas temperature is within an acceptable range. The cycle times of the two columns do not differ greatly from one another. The oxygen performance volume flow set is sufficient.